Okay, I hope it has started now. Okay, as I was telling you that our first topic will be dummy variable regression models. The second one would be multicollinearity. Okay, and we call it dummy variable regression model because of the reason why we use a dummy variable in this particular model. And as I have already told you, dummy variable regression models would be used in those situations, or this name would be given in those situations where one or more of the explanatory variables in your model is actually a qualitative variable, right? Qualitative variable, or another name for that one is categorical variable. So if you want to study the dependence of your dependent variable on an explanatory variable which is in the form of categories rather than in the form of numbers, then in such cases you use dummy variable regression model. So this is as far as the justification of dummy variable regression model is concerned. So I repeat, dummy variable regression model would be used whenever one or more explanatory variable in your model is qualitative, categorical, right? So dummy variable is an idea to represent a qualitative variable, a qualitative explanatory variable in your model. How we do it, you will see it in a short while. But I was just trying to explain what we mean by dummy variable. Dummy variable is an artificially created variable which takes only two possible values. One value is represented by the number 1 and the other value is represented by the number 0, right? Where 1 represent the presence of a particular characteristic and 0 represent the absence of a particular characteristic. Okay, so like for example, if you want to represent gender through the idea of dummy variable, then you have to decide which category of the gender is the gender of your interest, right? So if, for example, you want to study, if your category of interest is male as compared to female, then you would assign the code 1 to male, and automatically female would get the code 0. But if your category of interest in the case of gender is female rather than male, right? You want to, in a sense, get a situation for females as compared to males, then you would say, okay, I would assign the code 1 to the category female, and automatically the male, the other category, will get the code 0, right? So you say a dummy variable is a binary variable, a two category variable, in which one category takes the code 1 and the other category takes the code 0. Okay. If your qualitative variable has got more than two categories, what you can do, this I will just show you in a short while. Okay. So, but before I can just tell you how dummy variable idea is used to represent a qualitative variable, let me uh, open the Stata, okay? And I would like that all of you open the example data set that we are using for the last 2 or 3 lectures, okay? To file, then I will go to example data sets, and from the example data sets, I would open the usual data sets that we are using for the last few lectures, okay? So let me click use in front of the auto.dta. This data set will open. As you see on the screen, this example data set is now visible with the names of the variables in the top right corner of the screen. Now, in the previous lectures, I had told you, now keep in mind that in the current topic, dummy variable regression model, I have told you that the dependent variable is quantitative, but we are just bringing a change in the explanatory variable. So we are saying, what if explanatory variable is not quantitative, if it is qualitative, right? So the left-hand side of the model would still be representing a quantitative variable. You may also ask, what if the left-hand side, which means the dependent variable, is qualitative? So yes, uh, it is also one of our topic that we will discuss in one of the next lectures. But for the time being, I would say we are not changing anything as far as the nature of the dependent variable is concerned. So dependent variable is still quantitative, but we say, let us consider a qualitative explanatory variable. Okay. So therefore, for the time being, our focus is only on the right hand side of the model. We are not changing anything about the left hand side. Very soon, I would also come to that point. What if the dependent variable is also qualitative? So if you remember in the last lecture, like for example, if I just write down des in the command window, which is a short command for description of the variables in my data set. So you see, when I just write down des in the command window at the bottom of the screen and press enter, this is what you get on the screen. Okay, this is just a description, nothing else, but just a description of the variables in my data set. And I have used a simple command des here. Okay, and this is just telling me the short names and the titles. If you remember in the last lecture, I had told you that there are two variables in this data set which are actually qualitative, right? What are those two variables? One variable is the variable rep78, which represents the repair record in the year 1978. And the other variable in this data set is the last one, which is titled as form. And what is the label of this variable? Car type. Car type, okay? Uh, and if you just go to the data editor, if I click this button at the top below statistics, if I click this button which says data editor, so the data view will occur. Okay, so in the data editor, as you can see here, there are two columns. One is headed by rep78 and the other one is headed by form. These two variables in my data set are actually not quantitative. Although, interestingly, you can see the numbers in the columns headed by rep78. Like you can see the numbers uh, which range from 1 to 5. There would be, against some cars, you would see the number 1, while against some of them, you will see the number 2, right? As you can see here. There are some cars which are assigned the number 3, and some cars which are assigned the number 4, and there are some cars which are assigned the number 5. But remember, the details description of this data says that this variable is actually not quantitative. This is actually qualitative, where the numbers 1, 2, 3 are not representing how many times the car was repaired. Okay, rather the 1, 2, 3, 4, 5, which you can see in this column, represent how much good or bad the repair record of a particular car was. So 1 represents uh, an excellent repair record, right? If any car gets the code 1, like for example this one, serial number 40, or star 5, this is just the particular car, it is getting the code 1. So code 1 means that this car is having the best repair record, the excellent repair record. By that we mean that this car was sent to the workshop for a very little time or not that much often in the whole year. Okay, and then uh, the other extreme is 5. Like for example, at serial number 43, this particular car has got the number 5 in this particular column, and 5 represents the worst repair record. So therefore, uh, 1 to 5 represent the repair record, where 1 is showing one extreme, the best record, which means that the car was not required to repair that much, while 5 represents the worst repair record. Worst repair record means that this car was sent more often. Most of the time, it was actually going to the workshop for repair. So that's why. So therefore, this 1, 2, 3, 4, 5 that you can see in this particular column, they are not actually 1, 2, 3, 4, 5. They are just codes representing 5 different categories. Similarly, if you look at the last column, which is headed foreign and whose label is car type, as you can see here, right? Car type, and all the uh, all the 74 cars in this particular data set were divided into two categories. As you can see here on the screen, the first 52 cars were labeled as domestic cars, while the rest of the cars from serial number 53 up to 74, right? These 22 cars were labeled as foreign cars. So they were not local, which means they were not locally manufactured, or they were not belonging to the US companies. They were actually foreign companies. As you can see here, like Honda Civic is Japanese, okay? BMW, for example, is BMW, Audi, they are German cars, etc. Okay, Toyota is Japanese car. So therefore, any car which is not belonging to a company in USA, right, that was declared as a foreign car. So there, and as you can see here, when I click on foreign, you can see the number 1 here. Actually, foreign is coded as 1, and okay, domestic, if I click a domestic, you can see the code 0 here. So actually, this foreign is also coded as 0 and 1. But important thing is that the 1, 2, 3, 4 that you can see in the column of Rep 78, they are not 1, 2, 3, 4. They are just categories, like the codes used for 5 different categories. So therefore, uh, and I can also show you, like for example, in Stata, if you want to get a frequency table for a categorical variable, then you simply use the command tab. Okay, let me just show you. Just type tab in the command window. Tab is a command for getting a frequency table, and this command is always used for qualitative variable, right? Do not use this command for quantitative variable like price, MPG. Use it only if you know that the variable that I want to study is qualitative. So we will use it for Rep 78 and the form. So when you say tab and followed by the name of the variable, like for example from the variable view, I would just put my cursor on Rep 78 and click this arrow, okay? So that the Rep 78 comes in the command window, as you can see here. It is coming here. So tab, then with one space, Rep 78. If I press enter, you see on the screen, this is what you get. This is actually what we call the frequency table. And the purpose was just to show you that the 1, 2, 3, 4, 5, which are occurring in that column, are actually not 1, 2, 3, 1, 2, 3, 4, 5. They are just representing the categories. So when you look at the word frequency, they are just representing how many times 1 is occurring in our data set, how many times 2 is occurring in our data set, and so on. So the frequency of the code 1 is 2. It means there are 2 cars in this data sets which has the repair record represented by the code 1. And what is the code 1? It represents the best repair record. So there were 2 cars in this data set which has the best repair record. So they were not sent to the workshop most of the time. And then 8 cars were having a repair record which was coded by 2. You can give it some name, but for example, you can say that repair record ranges from 1 to 5. So 1 is best, and then gradually shows the worst situation, and it just represents the worst at the code 5. So you can see 30 cars in this data set is representing a repair record coded by the number 3. 18 cars have got this repair record, which is represented by the code 4, and 11 of the cars have got the worst repair record because it is coded by 5. So this is what we call the frequency table. So therefore, when I give the tab command to followed by the name of the variable rep78, I just want to know how many categories this rep78 has got. So 5 categories represented by this. When I just get again the command tab, and now when I click, for example, the foreign from the variable weave, okay, tab followed by foreign from the variable weave, and press enter. So you see, I'm getting this thing that how many cars are domestic and how many cars are foreign. So car type represented by the short name of foreign is also a categorical variable, but it has got 2 categories, right? The category domestic represented by the code 0, and the category foreign represented by the code 1. So therefore, rep78 is a 5 category variable, while foreign is a 2 category variable. Now, before I can show you how this dummy variable regression model is fitted, imagine that I just want to study fit econometric model in which price of the car is dependent variable. Okay, like for example, let me just write a comment like this. Okay, fitting a model to study the effect of rep78 on price. Okay, now suppose this is the thing that I want to do. Fitting a model to study the effect of, I have put a star before this comment because when you put a star at the beginning, so Stata would consider anything after the star as a comment. So therefore, it would not be executed or it would not give you any error. So suppose my purpose is to study the dependence of the price of a car on this variable, which means my dependent variable remains the price, but now my explanatory variable is rep78. Now, if I just do it like this, okay, let me show you. I am now first fitting a wrong model, and then I will tell you why it is a wrong model. Okay, what you will see on the screen right now would be actually a wrong model. Reg, because up till now we say if you want to fit an econometric model in which price is dependent variable and rep78 is an explanatory variable. So what you do, you just do it like this: price, reg followed by price, and then followed by the name of the, so this is like reg followed by the y variable and then followed by the x variable. You see, I get my model. Although from the first part of the model, we get the idea that this fitted model is insignificant. As you can see here, the p-value associated with the f statistic given by this ANOVA table, the p-value is 0.9574, which is much larger than 0.05. So this fitted model is insignificant, and therefore there is no need to consider this model, which is something that I had told you in the last lecture. But for the time being, if you ignore this information that, for example, my purpose is not to determine whether this model is a good model or a bad model. My purpose is to tell you why this fitted model is actually a wrong model. So when I tell you that this is a wrong model, then it doesn't make any difference whether it is significant or insignificant. Okay, so if you say this is how I'm doing it until now, so you see the software is not giving you any error message. It is just giving you the model, right? Irrespective of whether it is significant or insignificant. Okay, but if you look at the fitted model, let me just show you something. Okay. All right. So now consider this portion of the output. This is what we call our fitted model. Okay. This is what we call our fitted model. And for the time being, just as I have already told you, just ignore the fact whether the fitted model is significant or insignificant, but we just say this is our fitted model and we want to interpret. As you see, we have got our fitted model. This is like beta naught hat 6080.379, and this is beta 1 hat 19.28 something. So our x variable here is rep 78. Okay. Now the thing is, if you want to interpret the meaning of this fitted model, okay, which means if you want to interpret the meaning of this number, so until now, our understanding of the coefficient of our explanatory variable was rate of change. We say that you would interpret this number as rate of change. So change in y corresponding to a unit change in x. So if we keep continuing our interpretation of the coefficient of our explanatory variable in that way, so how can we interpret this number? We will interpret this number as, for a unit change in rep 78, the price of a car increases because the sign is positive. The price of a car increases by $19.28. Mechanically, there is no problem in this interpretation, but conceptually, this is totally wrong. Because we are saying that as rep 78 increases, okay, as rep 78 increases, then the price increased by this much on the average. Then we have to ask ourselves what we mean by a unit increase in rep 78, right? If rep 78 is a quantitative variable like MPG, right, or weight or length, then it doesn't make any problem for us, because we say as weight increases, then the price of a car increases by this much, or as the mileage increases, then it increases. But now rep 78 is a categorical variable, which has got these different categories that we saw over there, from best to worst. So what does it mean when we say that as the repair record increases, right? Keep in mind that rep 78 represents repair record. So if we say that for a unit increase in rep 78, the price of a car increases by $19, it would not make any sense, because the repair record, which is in the form of best record up to worst repair record, So there is no concept of increase or decrease, right? The repair record can only change from one category to another category, but it cannot increase or decrease. So we fit the model, but conceptually this is a totally wrong model. Okay? So if we fit a model like this, whether it is significant or insignificant, irrespective of what is your result here, right? Whether you get a significant model here or whether you get an insignificant model, but if you fit a model in which you consider a qualitative explanatory variable just like a quantitative explanatory variable, then this particular result that you will get would be totally wrong. So then it gives us the idea that what should we do so that we have a correct interpretation of the effect of a qualitative explanatory variable. So I repeat, in the current form, if we want to interpret the meaning of this 19.280112, our interpretation would be that as Rep 78 increases by 1 unit, the price of a car would increase on the average by 19.28, which is totally wrong. Okay? So this doesn't make any sense. Why? As I've already told you, repair record, there is no concept of increase or decrease when it comes to categorical variable. To explain this point, let me just fit one more model and then I would come to the idea of dummy variable regression model. Now consider that now we change our explanatory variable, okay? Now we change our explanatory variable, and rather than studying the dependence of price on Rep 78, we want to study the dependence of the car type, the price on the car type, right? So we want to fit this model. Okay, fitting a model to study the effect of car type which is a one explanatory variable on price of the car. Now suppose our y variable remains the price of a car, but now our x variable is car type, which is again a categorical variable, right? Which is again a categorical variable in the form of domestic, as you can see here, domestic and foreign. But suppose for the time being, if we ignore this fact and we fit it like this, reg, okay, followed by the dependent variable price and then followed by the independent variable foreign. Okay, if we just fit it like this, we get this model, and again forget about this result which tells us that the fitted model is insignificant. Okay, forget about this one, but just come over here. Again, this number tells us the effect of the variable foreign, okay, on the variable price. So what is the effect of foreign, which is actually representing car type, on the price of a car? Okay, in a sense, we want to determine whether it makes a difference if the car is a foreign car or if the car is a domestic car, what effect it has being a domestic car or being a foreign car, what is the effect on the price of a car. Okay, because our understanding will tell us that a foreign car should be more expensive as compared to a domestic car. But if we fit the model like this, we get our fitted model here, and this number 312.2587, this number then tells us something about the effect of the car type, the variable foreign, on the variable price, the price of a car. But the problem actually comes when we want to interpret the meaning of this number. So in the usual interpretation, we would say that this again, using the rate of change idea, for a unit increase in foreign, the price of a car increases on the average by $312, which means if foreign increases by 1 unit, what is foreign? Car type. So we are effectively trying to say that if the type of the car increases by 1 unit, then the price of a car increases by $312. And then you would ask yourself, what does it mean when we say if the car type increases by 1 unit? Because you know that car type is not quantitative. It is actually qualitative in the form of two categories, domestic and foreign. So when you say that when the car type increases by 1 unit, then you say, what does it mean? It doesn't make any sense. The type of a car cannot increase or decrease, right? It is not any quantity which will increase or decrease. It is just a category. It can be either foreign or domestic. So although you can say that if the category of the car changes from foreign to domestic or domestic to foreign, then what would happen to the price of a car? But it would not make any absolutely any sense if you say that if the type of the car increases by 1 unit, then the price of the car would increase by $312. So here you then discover that this whole discussion doesn't make any sense. So this actually gives us the, so therefore this model is also a wrong model, right? So if you fit a model like this, you will end up with a totally wrong model, irrespective of whether you have got a significant result here or whether you have got an insignificant result here. It would not make any sense. If the model is wrong, all other discussion just become irrelevant, right? Significance or insignificance तो आप तब देखेंगे overall or individual अगर model makes sense. If the model does not make any sense, then forget about any interpretation of the model. Okay, so what is the basic flaw over here? The basic flaw is that you are ignoring one fundamental fact when you are fitting models like this. Like when you are just considering something like this, or when you are considering something like this, you are ignoring one simple fact, and that fact is that you are treating a qualitative explanatory variable in the same way as you will be considering a quantitative explanatory variable. Okay? So, if you are, for example, if you are fitting a model like this, like reg followed by price, and then followed by, let's say, MPG, which we have done before, okay? Then in that case, this particular thing, this particular number, if you interpret it like this minus 238, you can say that for a unit increase in mileage of the car, the price of the car decreases or gets down by $238. So this is absolutely a correct model. Why? Because MPG is a quantitative variable. But why it doesn't make any sense here? Because the variable foreign, right? The variable foreign is not quantitative, it is qualitative. Similarly, the variable rep78 in the previous case was qualitative. So then it gives you the idea that there should be a different approach when it comes to representing or using a qualitative explanatory variable in your model. So let's just use that idea. So the econometric theory is actually telling you that if you are dealing with a qualitative explanatory variable, okay, if you're dealing with a qualitative explanatory variable, then you should represent it by dummy variable, okay, by dummy variable. So in the dummy variable idea, what we do, we just define a variable d, okay, which will take the value 1, right? Uh, for the category of interest, right? And it will take the value 0, okay? Otherwise, let me just write it like this. So a dummy variable is a variable which just takes these two uh, numbers, right? It will take the value 1 for the category of interest, and it will take the value 0 otherwise. So there is also a particular rule that you will see in the document that I will send you, uh, which we call the dummy variable rule. Dummy variable rule, right? And this dummy variable rule says uh, a qualitative explanatory variable uh, having uh, say so k categories is represented by k minus 1 dummy variable. This is a rule that you should always remember. If you want to decide how many dummy variables should be used to represent a particular explanatory, qualitative explanatory variable, qualitative or categorical explanatory variable, okay? So you just count the number of categories, okay? You just count the number of categories, okay? In general, we say if the number of categories of a qualitative variable, qualitative explanatory variable is k, where k would be some number, uh, 2, 3, 4, whatever, because the minimum number of categories is 2 and the maximum can be any. So if, in general, if there are k categories of a qualitative explanatory variable, then it would be represented by how many dummy variables? K minus 1, which means 1 less. It means that, for example, if k is equal to 2, right, then k minus 1, right, is equal to 1. Like, for example, if a variable has got two categories, like, for example, the car type that you just saw, or, for example, the gender of the respondent, or, for example, ownership of a house in the form of yes or no. So if the explanatory variable is a two category variable, then how many dummy variables you need for that? Just one. But if the number of categories of a categorical variables are equal to 3, like, for example, the font size, small, medium, large, then how many dummy variables are required to represent that? It would be 2. 2 dummy variables are required, okay? And, like, for example, if in the given case we have a variable rep78 which has got 5 categories, so how many dummy variables you need to represent the variable rep 78, you need 4 dummy variables, okay, where the dummy variables would be defined in this particular fashion that I have just written over here, okay. For every category of the explanatory variable, you would define the dummy variable in this way. Like for example, for the variable car type, you can say that D would take the value 1, right, if rep 78 is equal to 1, and this will take the value 0, okay, otherwise. So you can call it, for example, D1, okay, D1. So D1 would be one dummy variable, okay, which in a sense would represent this category of rep 78. If you want to represent the second category, like for example, the 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 category represented by the code 2, so you can say that D2 is another dummy variable in my data, which will take the value 1 if rep 78 is equal to 2, and 0 otherwise. Otherwise means if any other category, okay. And similarly, you can define D3 for rep 78 equal to 3. You can define D4 for rep 78 equal to 4 or D5. But the dummy variable rule is actually telling you that although in general, the number of dummy variables that you can define in this way, would be equal to the number of categories of that particular categorical variable. But the dummy variable rule is telling you that in order to represent a categorical explanatory variable in your model, you should not use k dummy variables. The number of dummy variables representing an explanatory variable should be one less, as you can see here, k minus 1, right? Why you use one less? Okay, the reason is actually multicollinearity that I would explain after this. So in order to avoid a case of perfect multicollinearity, which severely affects your model estimation, you say I would not fit k dummy variables, I would fit one less, right? Whichever category is not considered for the dummy variable, that is then called what we call the reference category. And I will just tell you what we mean by that. So therefore, the dummy variable rule is actually saying that first count how many categories the explanatory variable has got. If it is k, which would be a number 2, 3, 4, whatever, then how many dummy variables you need? One less than that, okay? So if the number of categories of a qualitative explanatory variables are 5, then you need to consider 4. How many, which particular 4, I will tell you in a moment. So this is actually how we do it. Okay, let me go back to Stata and tell you, like for example, when I fitted this model, reg price and rep 78, okay, and I got this result, then I told you that this is actually wrong, okay. This is what we call a wrong model. The reason was that if you want to interpret this portion of the output, then this portion of the output is actually totally wrong. So we need to represent rep 78 correctly in this particular model, okay. So this rep 78 should be represented correctly. And for that, you saw that this rep 78, okay, for that you saw that this rep 78 has got these 5 categories. So what I will do, I will in a sense, create four dummy variables because the k here, right? In the given case, here, what is k? K is equal to 5. K is equal to 5. So what would be k minus 1? K minus 1 would be equal to 4. So therefore, for the explanatory variable rep78, and using the dummy variable rule, how many dummy variables we need? 4, right? So we will be using that one. If you want to create the dummy variables yourself, you can do it, but that would be, in a sense, a comparatively time-consuming approach. So Stata has got a very good facility, which at least I have not seen in other softwares. In other softwares, you have to actually create the dummy variables and then put it into the model. Stata has a direct way of not only creating the dummy variables, okay, but uh, also inserting it into your model. So if I want to keep the last category, okay, this one, if I want to keep this category as the base category, which means that I need four dummy variables representing these four categories, and